My name is Sera Markoff, and as you can tell, I'm American. The path to coming here, I don't think was a very straight one. We have a very different educational system in the US, right? When we're young, we don't get separated into science, arts, like beta, gamma. We actually don't have to decide what we do with our lives till we're about 20, 21 in the university time. So the first 2 years of university are broad, and then you pick something more focused. So I think, in fact, if I had been asked to pick science when I was 15 or whatever the age is here, I probably wouldn't have done it. I was doing more art. I was interested in artistic things, but I was always good at math, and I liked philosophy, so I was attracted to the idea of cosmology and astrophysics because I think it's as close to real philosophy as you can get and actually find something out. So basically I got into MIT, which is a very intense kind of scientific university in the US, and I didn't really think I was going to graduate. I thought, well, I'll try it, see how it goes. And then I did graduate, and I ended up doing research as an undergraduate, which you can do also here, and that's a bachelor. Sorry, I have to translate. So as a bachelor, I did research. And then I thought, well, I don't know if I want to do this. But then I got into a graduate program, and I thought, well, okay, so I did my PhD. Then I thought, I don't know if I'll still do it. So it's been kind of, step by step. But the point is, it's a very interesting subject, so that's why I kept doing it. I teach classes to both bachelor's and master's students. I organize the colloquium series here, which is when we have outside visitors come and give talks. And I supervise the research of about 5 people at the moment. I never liked the idea of having kind of a normal 9-to-5 job, doing the same thing every day, never using your brain. And there's lots of jobs where you can use your brain, but every day is different in my job, and I do lots of interesting things. So that's, in a broad sense, why I think it's interesting that you have a chance to think about something different. But I think black holes are they're very exotic. They're very strange objects. They were actually predicted, theoretically, just from math before we ever found them. And I think that's a very fundamental thing. I mean, that's one of the things Einstein sort of did. It led to it led to this prediction. And that's a very deep thing, that you could just write some equations down on a piece of paper and maybe predict something that's really out there. So for me, I find them very exciting. They're kind of cutting edge, and also they're pushing physics to these boundaries that we don't know. So it's like you get to do something that is really different from everyday life. So when stars die, big stars, you get black holes. These are called stellar remnant black holes or galactic black holes, and there are thousands of them in every galaxy. We think maybe even more. And a black hole is something obviously you can't see, right? But what happens is, if something's around it, gravitationally will pull the material in, and it gets heated up and basically gives off light, just like if you do, friction and you rub your hands together, it gets hot. It's the same thing that happens to this material. It comes in, it gets stuck together, it starts heating itself up, and you get radio, X-ray, infrared, all these different types of emission. So what we try to do is study this matter that falls into black holes, and we look at this with many telescopes, and then we use this to try to model it with physics, to make a physical picture to understand what happens when the gravity gets very strong, because when you get near a black hole, gravity is extremely strong. In fact, light can't even escape. But we also get these huge jets of material that splurt out, and they're actually really, really big compared to the systems. So I try to understand the physics of how this happens, and I compare the little black holes to the big black holes and try to see if the physics is really the same over, these are billions of times different in size. So the public, I think, is generally very interested in black holes and in astrophysics and so on. So in a way, it's also doing a service, because it's like we give science fiction writers something to do. There's been quite a few studies internationally that show that if there's one single predicting factor for how you're going to do in almost any job, it's how well you are at math. And this is true. They found out that, in fact, students who studied biology earlier didn't do better with biology than the people who studied math earlier. So math and physics, whether you actually end up doing these things as your career, I think they teach you how to think. They teach you how to think logically, to reason, to be smart about things. And so it's a real skill that you can use, you know, if you go into business, if you go into even the arts or anything. I think that's something that's worth doing, even for a bachelor's program. But of course, if you go into research, it's just a very exciting thing to do, and you can actually turn it to help humanity if you want. I mean, you know, for people don't think about this, but the internet didn't come because we invented the internet for, you know, kids to use MySpace. We invented the internet because scientists at CERN were trying to talk to each other. So you can't predict how these things will come out. And also, if you wear Gore-Tex when you're cold and you're hiking or skiing, do you know what I mean? This waterproof fabric. Well, it was invented by NASA for astronauts, and now we use it every day. So I think you can't predict where it's going to go.